and gentlemen, please take your seat. Ladies and gentlemen, before we start the event today, let us join together in prayer that will be led by Dr. Juni Andri Sulistyo, MD.
Assalamualaikum warahmatullahi wabarakatuh. Let us bow our head for a moment. Pray to God Allah Subhanahu wa Ta'ala so that our international conference can be precious to all of us. I will lead this prayer based on the teaching of Islam, and those who are not Muslim, you are pleased to pray according to each of our belief. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan syakirin, hamdan na'imin, hamdan yuafi mukafi mazida. Ya Rabbana lakal hamdu kama yanbaghi lil karim wa adimi sultanik. Rabbana dhalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana la tuzigh qulubana ba'da idh hadaytana wa hab lana min ladunka rahmah innaka antal wahhab. Allahumma inna nas'aluka taubah wal inabah wal istiqamah ala syari'atil ghara wa tariqatal bayda'i bi rahmatika arhamar rahimin. Allah, today we gather here to bring about the international hybrid seminar. The theme is innovation and climate change adaptation for coastal and delta areas. Make this international conference as the civil science assembly as a medium of sharing useful ideas, knowledge, and experience of scholars, researchers, and students of various disciplines. May the conference we organize today benefit to our lives, broaden our knowledge, send our ideas, and lead us to be successful, productive person, which in turn will boost dignity of our nation. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Sallallahu ala sayyidina Muhammadin wa ala alihi wa sahbihi wa baraka wa sallam. Subhanaka rabbika rabbil izzati amma yasifun. Wassalamun alal mursalin walhamdulillahi rabbil alamin. Surah Al-Fatihah. Assalamualaikum warahmatullahi wabarakatuh.
The next agenda is opening speech by the Dean of Engineering Faculty. We please Mr. Abdul Rahim to come to the stage.
Okay, please let me repeat the first. Assalamualaikum warahmatullahi wabarakatuh. Your Excellency, the Vice Rector of UNISSULA, distinguished guests, ladies and gentlemen, welcome to Faculty of Engineering UNISSULA for the International Hybrid Seminar held under the theme Innovation in Climate Change Adaptation for Coastal and Delta Areas. I would like to thank everyone here today for being part of this event. As the Dean of Faculty of Engineering UNISSULA, it's an honor to have so many distinguished and high-level speakers on the agenda, and to welcome hundreds of participants from all over Indonesia. I would like to thank and welcome our distinguished speaker with us today. The first, Dr. Hanif Faisal Nurofik, SWOT MP, the Minister of Environmental of the Republic of Indonesia. Professor Dr. Floris Boogaard from Hans University of Applied Sciences, the Netherlands. Professor Erik de Boer from Hans University of Applied Sciences, the Netherlands. Prof. Ricky Vogel from VIA University College, Denmark. Professor Dr. Theis Andersen from VIA University College, Denmark. And Professor Dr. Insinyur S. Imam Wahyudi DA from Universitas Islam Sultan Agung. I would like to thank to our moderator today, Dr. Hermin Pujastuti, for guiding the seminar. I would also like to address great thanks to all those who have been involved in organizing this event. Excellencies, ladies and gentlemen, this seminar allows us to examine and discuss the main issues and opportunities concerning the climate change. In Semarang, in the last 2 decades, the habitat living in low-lying area has suffered a lot from inundation. Even in the area not far from Semarang, there is a sinking village called Timbul Slogo. I think it must relate to climate change we face now. When fossil fuel are burned, they releases a lot of carbon dioxide, which is a greenhouse gases. Accumulation of greenhouse gases warms up the earth. According to data from NASA, in the last century, the surface temperatures has risen 0.8 degrees Celsius, and a study from Yale University find world losing ice 57% faster than in the 90s. In the last century, the increase of temperatures 8.8 degrees Celsius has caused the increase of sea water level 20 centimeters. Due to this increase, coastal area will be covered by the sea when sea level rises. Flooding in low-lying area will become more frequent. With a 2 degrees Celsius temperature rise, it's predicted that the sea level will rise by another 50 to 70 centimeters. Land area that will be submerged due to the sea level rise will displace 200 million people. It's projected that 115 islands in Indonesia will be submerged by 2100. Future climate with warmer air, for every 1 degree Celsius more that air warms, it can hold about 7% more water, which is creating heavier rain. This could lead a greater risk of flash flooding. The last but not least, we hope that this seminar will give us perspective on how to adapt to climate change, and also we hope that this seminar will be fruitful discussion. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Abdurrahim STMT. And ladies and gentlemen, now we will move to welcoming remarks from Vice Rector Universitas Islam Sultan Agung, Mr. Andre Sugiono STMM PhD, that will catch up with us in virtual room.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hopefully my voice sounds clear there. Good morning everyone. Good morning to you all, especially Your Excellency Dr. Hanif Faisal Nurofik, Executive MP, Minister of Environment of the Republic of Indonesia, or the representative that coming to our campus. Our distinguished speakers, we have 5 distinguished speakers. Professor Floris Boogaard, Professor Erik de Boer from Hans Hogeschool Netherlands, and then Professor Theis Andersen, Professor Rika Marford from the IA University College Denmark, and also Professor Imam Wahyudi from UNISSULA. Also, Dean of the Faculty of Engineering UNISSULA, Dr. Abdul Rahim, along with the Vice Dean and also the lecturers, all students, participants, ladies and gentlemen. Thank you very much for the invitation. All praise to Allah Subhanahu wa Ta'ala, the God Almighty, who has shown us with the abundance of blessings. Also, salawat and greetings may always be upon to our Prophet Muhammad Sallallahu Alaihi Wasallam, while longing for his shafa in the Judgment Day. Your Excellency, distinguished guests, ladies and gentlemen, on behalf of Rector UNISSULA, Professor Dr. Gunarto SMH, I would like to welcome you all in Universitas Islam Sultan Agung, UNISSULA, Semarang City in Indonesia, for the International Hybrid Seminar with the theme Innovation in Climate Change Adaptation for Coastal and Delta Area. UNISSULA, as the best private university in Central Java Province, has been recognized globally, as we know that it is reflected in our achievement since 2022. We already in the top of global world university ranking. Our achievement in the science higher education, we already ranked at 401st. Also in the Asia of yes world university ranking, we already in the top of 169. So it is reflected in all of our agenda. Like today, we have international seminar. First, with this seminar, we can have some bigger responsibility. With this seminar, we can give some contribution to tackle our problem as a global community with this climate change. UNISSULA, as a higher education institution, is always committed to contribute more to address this problem. We already know that in the global university ranking. There are impact ranking that show us university contribution to the sustainable development goal, which is the climate change is on the 19th one of sustainable development goals in globally. So through this seminar, we can give some contribution to various ways, including education, research, community impact, and day-to-day operation based on the environmentally friendly approach as an example to our university. Your Excellency, distinguished guests, ladies and gentlemen, the theme of the seminar today reflecting our efforts to find the solution through innovation to address the climate change adaptation by the participants of four professors as speakers from the Netherlands and Denmark. Also, hopefully we could make our discussion today more insightful, lively, because this seminar is not hybrid, so the participants online can give also question today. We also hope that this seminar will inspire us all to do more in solving problems caused by climate change. Finally, I wish you fruitful and inspiring seminar today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you so much for Mr. Vice of our rector. So, ladies and gentlemen, now we will go to the main agenda today. There is discussion. So, actually, today we have the Minister of Environment of Indonesia Republic, but unfortunately, the Minister, for one thing and another, he cannot come today. So, we have 5 speakers today, and with Bu Hermin as the moderator. Please, Bu Hermin, to come to the stage. So, ladies and gentlemen, let us read brief about our 5 speakers and our moderators today. The first speaker is from Hans University of Applied Sciences. He is Boogaard. Floris is a professor whose study focuses on climate adaptation and optimizing the long-term efficiency of urban-based solution. He is a researcher at Building Climate Adaptation Field Lab in Groningen. And the second speaker is Eric de Boer. Eric is an academic professional at the Institute of Architecture, Built Environment, and Civil Engineering of Hans University of Applied Sciences. He specializes in sustainable, innovative solutions within the fields of architecture and civil engineering. The third speaker, Wahyudi, Professor Imam. He is a professor in theology. Prof. Imam often get a grant, both national and international grants, such as Erasmus+. He also initiates Delta Center in Indonesia, and now Prof. Imam is the head of doctoral program of civil engineering.
Okay, and the next, our speaker is Professor Theis Andersen. Mr. Theis is with over 10 years of experience in involvement in 20 plus research projects contribute to advancing knowledge and climate adaptation, water technology, and near-surface geothermal system. He works within 3 research and development centers, built environment, water technology and climate, applied textile, design, and circularity. Okay, and the next speaker is Professor Rike Mark Boogaard. Okay. Mr. Rike is Mrs. Rike is microbial ecology, leads the research center of built environment, climate, and water technology in Via University, Denmark. Her work focusing in mitigate environment footprint and adaptation to climate change in construction. Okay, ladies and gentlemen, now it's time for us to have some discussion with amazing keynote, and this session will be led a great moderator, Dr. Hermin Pujiastuti SSI MSI, is a member of the Ikatan Ahli Teknik Penyihatan Indonesia with significant experience in consultancy projects. Her expertise spans water resources management, environmental impact analysis, and various construction projects, building reliability inspection, and solid waste management initiatives. Okay, Dr. Hermin, please lead the discussion. Time is yours.
Of course, we remind you, all of participants here, both offline in this room, also online participants, don't go anywhere, and please prepare your question because the discussion will be very interesting and interactive, so don't go anywhere, guys.
Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, good morning, ladies and gentlemen. Welcome to the International Hybrid Seminar entitled Innovation in Climate Change Adaptation for Coastal and Delta Areas. My name is Hermin Pujiastuti and I will be your moderator for today's session. Today we are excited to have you with us both online and in person as we explore some completing insight from our distinguished speakers. Before we dive into the presentation, let me take a moment to outline the agenda for today's seminar. We have 5 experts, speakers who will share their insight and experiences on effective adaptation strategies that can be employed in coastal regions. We'll explore various approaches ranging from nature-based on solution to community engagement practices that empower local population to take change in their resiliences. I encourage all participants to engage actively in the discussions, ask questions, and share your perspectives. Together, we can work towards fostering sustainable solutions that will help protect our vulnerable coastal areas for generations to come. Today's agenda is packed with exciting presentation, panel discussion, and opportunities for engagement. We have some note to make before we begin the keynote speakers session. We will start with our keynote speeches, followed by a panel discussion. For participants in virtual room, please kindly mute your microphone and on camera when keynote speaker session to ensure that this event runs smoothly. And we will conclude with a Q&A session where we encourage your participation, and then questions can be submitted after all speakers have presented their presentation. If you are in the audience, please feel free to raise your hand and I will bring the microphone to you. For those participants online, can be delivered directly by clicking the raise hand button or indirectly through the meeting chat. Thank you for your attention and cooperation. Before the dive into our session, I would like to acknowledge our distinguished keynote speaker who will be sharing their insights with us today. Let me take the opportunity to introduce them. The first, welcome to Semarang, Professor Dr. Floris Boogaard and Professor Erik Boer from Hans University of Applied Science, the Netherlands. And then beside me, welcome to Semarang too, Professor Dr. Theis Andersen and Prof. Rieke Mark Fouquet from via University College, Denmark. And then the last presenter, please welcome Professor Dr. Selamat Imam Wahyudi from Universitas Islam Sultan Agung, Semarang. Ladies and gentlemen, continue the next schedule. We would like to invite Prof. Floris Boogaard from Hans University of Applied Sciences as our first keynote speaker today. Mr. Floris Boogaard, please welcome, and time is yours.
Thank you so much. Yes. Assalamualaikum. Terima kasih for that we can be here. As you can see from my batik shirt, it's not my first time. We have a long cooperation, so yeah, thank you for being here, seeing so many friends, and being here with our Danish friends as well makes a very warm welcome. I will give you a short introduction on the Dutch perspective. I will do that also for my colleague Erik de Boer. So I will do the presentations, and all the hard questions we can ask to Erik. Is that a good plan? I would say. So do we have the presentation? Yeah? Then as a short introduction, there's a lot to tell, of course, about climate adaptation in the Netherlands, as you can see from the board as well. It's quite a long title, so I thought I'd tell you something about the climate challenges that we face in the Netherlands, also about some of the solutions that we have. That's advanced water management systems, so very high tech, but also some small scale urban based solutions that we are equipped with the last time. And of course they all come with opportunities but also with challenges. So it's mostly about sustainable urban planning. So I will just give you some brief insights in what we actually do. And of course, this is a short introduction. It's 30 minutes, about 30 minutes. So I will also give you some more info. So if you are really interested in this topic, I can show you where to start. So this is a short map of the Netherlands and also the occupations that I have. I'm a professor at Hans University of Applied Sciences in Groningen, as been told. I'm also a researcher at Deltares, independent research institute that actually does the calculation of the water management system in the Netherlands, so the dikes and everything. So that's another occupation. And from that, if we click to the next slide, you will see how the Netherlands will look if the dikes would break, because most of the Netherlands is below sea level. So yeah. So this is, I would be out of a job, right? If the dikes would break. So this is all below sea level. So the lowest point in the Netherlands is 8 meters below sea level. So it's quite dangerous, and because of subsidence and sea level rise, this will be higher in the future. So you can imagine that we have a lot of challenges in the Netherlands to face. Thank you. Yeah. So this is a short introduction of the Hans Applied University. We do research on floodings, of course, but also drought and heat stress and other climate related topics. So, yeah. Next slide. Or do we have a clicker, maybe? Is that something we have? Then I won't bug you with next slide, next slide. Just if we have, otherwise we do it like this. Yeah. Yeah. So this is a map from a lot of knowledge exchange that we do as a university. Some of the places, and of course you see Indonesia and the long cooperation that we have between the countries, but also the knowledge that we share also with our Danish partners. We share that with around the world. So also North America, for example. Because on this map, we're not the only ones that... oh, that's perfect. All right, great. Yeah. All right, now it goes smooth. Perfect. Yeah. So this is the map. Because, of course, this morning we had a talk about this campus, which is flooded quite recently. We have that same problem in the Netherlands, but also at other points in the world, like New Orleans, you probably heard, it's below sea level as well. And more locations in the world will have that problem in the future. So it's very important to, as we do at this seminar, to spread the knowledge. And I think what has been asked shows some case studies from the Netherlands, but also from other countries that we can learn from. What should we do? Should we higher up the campus as being done now? Or maybe go to floating urbanization? Or there are a lot of possibilities that we can do, but it all depends on the strategic decisions that we make. So here's a map of the Netherlands, and where you can see that the water comes from all sides. So of course it comes from the sea. Sea level rise makes it more difficult in the future. It also comes from the river. The rivers come from Europe, and mostly they leave in the delta, which is called the Netherlands. So that's another side. It comes from above, because we have more and more intensive rainfall. So that's something we have to deal with. And last, since we are below sea level, the water comes from the ground as well. It goes up, and especially in regions like 8 meters below sea level, you can imagine that there's a lot of pressure and a lot of water coming up, and that will be more and more in the future as well. So as you see, the Netherlands is quite a dangerous, seems like a dangerous place to live in. And of course, some incidents happened as well. In 1953, 2,000 people died because of the dikes broke in Zeeland, which is in the south part of the Netherlands. Devastating in the night. A lot of people were surprised, couldn't swim. So you can imagine that it was a catastrophe. And after that, because every incident that we have, of course, is being used to make a better plan for the future. And this date, 1953, every Dutch person would know, resulted in a Delta plan. A plan that should make sure that these things never happen again. And for that time, we installed a lot of advanced water management systems, which I'm going to show some examples of right now. So one thing we built was a 44-kilometer dike to shorten our coastline, because a lot of villages actually disappeared in the longer history of the Netherlands. And having a short line, it makes it more easier to protect all those villages which are in between. And this, of course, is almost 75 years ago that making a construction like that was actually considered a very high technical innovation. And on other parts as well, Zeeland, which was be flooded, you can see all the red lines there. There are storm surges. So they basically close when the sea is coming in. And some are permanent and some are open as well. So you can see that billions of euros have been pumped into this system, and since then nothing happened again. So we are quite safe, but of course this is a high advanced system to keep the Netherlands dry from floodings. So and of course, are we safe now with all those billions spent? Well, not actually, because the water comes from different sides, as I've been told before. Rivers come in, and rivers, they move with the high intensive rainfall, for example. So there were a lot of floodings every year. We see that also, and of course, in neighboring countries, in Belgium and Germany, but high floods from rivers still have to come to the Netherlands. So also the rivers need more space in the Netherlands because we live close to the rivers. So devastating parts. So we are never safe. That's basically the message that I want to give. And this is only about floodings. And it's only 30 minutes, but you can imagine that also there are some moments in time, as 2018, that for 2 months we didn't have any rain. That's a drought situation that we never had before, which is quite tragic because there were no ships in the rivers anymore. There was some infrastructure breaking down, but also heat stress. The higher temperatures with climate change, we're not equipped to higher long heat waves. So a lot of people actually die every high summer. So you can see that there are different challenges in the Netherlands, as you face as well, as water quality or biodiversity loss, that we have to come to an integral solution to come and face all these problems. Now the clicker doesn't move anymore. Can I maybe have the next slide? Or? Yeah. Okay. So, so this gives a bit of a link to other challenges that we have in the world as well, as heat stress and drought being very high in the agenda of the Delta program. And of course, there are a lot of reports about the world, the IPCC, that you probably know, that says that in the future it will be worse. Our storm surges will have to close a couple of times a year, and in the future that will be a dozen times, maybe even. So things are really changing. So we have a Delta program that basically in detail every year says what we have to do. And that changes as well. So there's more attention now for drought and heat waves than before. We were really a country that was focused on discharging the water, and that will change in the near future. And of course, what are we going to do in 100 years, where the lowest point in the Netherlands is more than 8 meters? Where the sea level rose, and we cannot be able to hire the dikes maybe to a certain extent and having more pumps pumping the water out. So in the future, we should change. But for now, we have some legislation that we cannot build near the rivers, for example, or and we have to enforce them as well. And these are some pictures of the Netherlands in maybe 100 years. So what should we do? Should we leave the lower parts and go to the higher parts? Should we actually move to sea with floating villages? Or so there are a lot of examples that we could do for the future, and that's not decided upon. But it's very important to think about the future and see what we're doing. And also from Indonesia and these parts, what is the solution to the problem in 100 years? Because subsidence will continue, the sea level will continue to rise, so there will be bigger problems maybe in the future. So, and that also comes to the city planning. And this is not the Netherlands, this is Central Park in Manhattan, but it's a very great example as what you can see, that green is in the middle and gray is around it. And that probably for some of the problems like drought or heat stress is not really the solution, because green should be everywhere. Water should infiltrate to replenish the groundwater levels. And also heat waves will not solve by one park in the middle, but it should be with shadowing all in between. And that's a bit about urban planning, water sustainable urban design or sustainable urban drainage. There are different names for low impact design or other planning activities that you could do to make cities more green and more resilient to climate change. And we as the Netherlands have been really about drainage. We mostly depended in the last centuries about underground drainage. So that's the gully pots that you can see here, and these are some of the locations that you have 7 gully pots on a row, really relying on the water to be underground. But the new intensive rainfall will not be enough to be only underground, so it will submerge, and that's a given. So it will really change our ways that we have to leave underground storage and just have the water below or on the subsurface being discharged. And that's really something for the future. So that's a planning activity as well. Because if you can see here floodings, and sometimes we get, as a consultant, you get pictures like this in China, you see submerged roads, but is that really a submerged road? I mean, you still can see the green, which is not having water, and the road as well. So it's really about urban planning and making the right decisions. Green should be lower than gray in this, so you can use the road, and green can have more room. And I think it's always quite hard to talk about these topics, but these artists make an impression on what maybe should be done as an urban planning strategy. As you see on the left, it's like a zipper, so all the roads should be open, so the water can actually penetrate in the road or being stored in the road. And then you have in the middle, you have scissors on a grass, that maybe the grass should be lower, so it should be a bioswale, or it should be like a green infrastructure, rain garden. And if we do nothing, that's the picture on the right, you can see that actually nature will take over. So nature-based solutions will actually take over the urban space. And that gives a lot of opportunities as well. These are some examples around the world with green walls. You can see actually stormwater drainage from a building with musical instruments. It's quite nice. If it rains, it makes a sound or a symphony, but also insect walls or green autarkic apartments in Thailand, for example. It gives a lot of opportunities to do urban planning in a different way, to be more resilient. And there are so many, more than 100 different green infrastructure that we can choose from. So that makes it complex as well. So what would be the wise thing to implement here in Semarang, for example? And also in the Netherlands, there's a lot of debate on what is the best infrastructure to make our cities resilient to the big rainfalls that we have. So then I would talk about some planning to address as one of the, and then I will show some case studies and then close where you can find some more info. So the planning part, mostly they're very complex. They talk about a lot of things, but it's mostly about analyzing your situation. What is the problem? How big is the problem? Then you, of course, you form your ambitions. So to say, what kind of rainfall event should be actually taken care of by the storage on the road, or what kind of sea level rise will we accept in the future with our dikes. So there are different ambition ways. And then lastly, of course, it's climate action. And it's not in a direct way like this. Climate action should be done now, so you can learn from it, and it's learning by doing, so it's evaluation as well. So that's, of course, very simple. Because if you have all the solutions give different costs and benefits. And it really depends on what is your main problem or your prioritization of the problem, what kind of benefits you will give to those to different solutions and implement them. And that's, of course, a lot of take. And I think case studies will help. This is a case study which is quite famous around the world. Singapore, in Asia, a good best management practices, which is about sponge cities. Basically says the same. It's about getting the water, keeping the water at a place that you can hold it, infiltrate to the groundwater, so you have enough drinking water for the future, and also have green for biodiversity and have a better water quality. So there are a lot of benefits in this case study alone. So, and then the big message is it's not only about flooding, it's about integral planning, and that has about to do with animals, with humans, with the public space, and a lot of benefits that you can actually implement in the solutions of urban planning. So, as I said, of course, it's not that easy to implement everything. There are a lot of things that come across, like Semarang is an urban dense city, also Jakarta, of course. You know, you don't have the place, you don't have the budgets maybe, so, and also all the residents of the city have to agree with this. So it's not an easy way or a one-way street that we can find our planning. And it needs a lot of capacity as well. That's why we have these seminars to tell about the different solutions in the future. So it's not that easy. What makes it more easy is to watch some case studies, like Bishan Park in Singapore, but also some case studies from the world. And what mostly helps are platforms where you can find solutions, because as I said before, other places in the world, they are facing the problems as well. So what kind of solutions do they have? And would they make sense for Semarang, for example? So these are a lot of case studies or platforms that you can use. One of them is being used in some case studies or workshops before. Here in UNISSULA, Climate Scan is one of them, which is basically open source. So you can use that as well. That makes it very participative, because that's one of the problems as well. We don't interact a lot with people that actually should say more about the urban plan. And how does that look? For the Netherlands perspective, we mapped about more than 10,000 solutions or projects that actually are an answer to climate adaptation. And everybody can put their project on the map at a different category, and that resulted in more than 100 solutions being mapped relating to water, so too much water, too less water, so drought, but also heat stress, or other like biodiversity. So you can go to that map, which is open source, and look for solutions that might be relevant for the Semarang case. So this gives some perspective to people as well, and what it makes quite nice is that everybody can use it. It's open source, it's out there for 10 years already, and it's of course not only for the Netherlands, it's also already in Indonesia, and showing some of the solutions that you already implemented and maybe could be upscaled as a solution to the world. So this is a video you can watch later. With that database, which is actually a database, you can also select which is the most popular, what is viewed the most. And this is from the Netherlands, which doesn't have to be representative, of course, for Semarang. But what you can see that there's a lot of green infrastructure. It's a lot about permeable pavements or storage on the road. It's about bioswales. It's about rain gardens. And these are quite popular in the Netherlands and easy to implement. You can do that in every street, and you should do that in every street to tackle the problems and the challenges that we have with climate adaptation. So, and these are, of course, just some solutions from the Netherlands, but there are more solutions around the world that we can see. So it's nice to see some faces there online. Let me see if this works. Yeah, because of course I can imagine that platforms that are more related maybe in English might be not the way to go. So that's why Climate Scan is also in Bahasa. It's called Brantasai. You can see, actually, you can go there, you can place your solutions. This is more related to water quality, but has been used in workshop also with UNISSULA to ask what kind of solution do you see. And you see some of the solutions from Semarang already on that database, which is floating urbanization, a floating library. You probably know that example, or otherwise you can look it up on the map and see what is out there, and also a floating restaurant. And of course, floating urbanization in the Netherlands, we have more than 50 locations where floating urbanization is already taken care of. It doesn't matter if there's drought or too much water. The infrastructure will just go with the water, which is probably a solution that we have to think of. But also maybe a bit further on, I'd like to show this example from Java. to other locations. I think it's quite clever because it's just making a bridge at location that we want to. Also this example in Jakarta, they already making the rain gardens, which were quite popular in the Netherlands as well. So I think it's a great solution already, which is out there, and it makes it possible to upscale that to different locations like Semarang. I haven't seen it here yet, but maybe I'm mistaken. If I'm mistaken, you can add that to the map as well and show the world what's out there. And this is another location in Germany. They just close when the water comes up, 1 week or 2 weeks. They just close everything up. It's watertight district, and the water comes in. They welcome the water. They don't fight the water, and they wait until it disappears. And this is just a short example of New Orleans. They had 2,000 casualties as well in 2006. In Katrina, they make a hill. When the water comes, you can flee and be dry, and also the houses are on stilts now. So they make districts now on stilts, they rebuild it, so that's also a way to deal with the water. So you can see a lot of examples. This is a Suriname, so you can go all over the world to see example. This is Vietnam. So there are a lot of countries that you maybe relate to more, where you can find solutions how they cope up with it. And also we talk about floodings, but maybe if it's the problems of drought, you can go to Africa. Cape Town is one of the cities that is coping with drought, where there's no water from the tap, for example, which they implemented a lot of opportunities and measures that we can learn from. And just closing up with some, because I'm going back to the Netherlands now, some last examples that we are working on. This is more about mitigation. So these are floating solar panels. And of course, that's maybe not an innovation, but these are floating islands, 24 hectares big, and of course, fighting CO2 emission by renewable energy, and which is, well, there are more than 20 floating solar panels already. And every roof in the future in the Netherlands should have been green on the roof, but not only green roofs, because that's not an innovation, but also polder roofs, as we call them. Most of the roofs will be able to carry like 50 meters of water, so they're more blue roofs. And the water is actually discharged looking at the weather forecast. So they're smart roofs with real-time control. So if it will keep the water, but if there a stormwater event is coming, it will release the water. So basically smart roofs. So a lot of roofs are being made green. Of course, you can use them as well as rooftops. It's a lot of subsidy programs from Dutch municipalities that use it. All the squares that are being built are made lower. So when rain comes, it will fill up the square, which will be filled for maybe a couple of days before the rainwater will go away. And so it stores temporarily, and most of the year they will be empty. And of course, we can use them in the urban space. So it's just very practical things that you can use. And also all the parks that we have will be made lower. So when water comes, it will flood the park and not the houses. And also when they're dry, of course, you can play, and they're multifunctional. So that's an integral way of planning, which is a quite big thing in the Netherlands now as well. These bioswales, there are more than 3,000 in the Netherlands. So every municipality already has these bioswales. So that's how we cope with it. And different locations like Amsterdam, of course, they have a different DNA than locations in the eastern part. Holland is a very small country, but still we have cultural difference around it. And these DNA of cities you can use from all the cities in the world. You saw someone of Cape Town, which is totally different from Amsterdam. And if we do this for Semarang or Jakarta, you can see a different DNA. Just saying that there's no one way to deal with this, but it's quite interesting. And the cost and benefits are very important to look at before you make your plan. So just to close up the conclusions, I think I showed some of the urban planning possibilities and how we do that in the Netherlands. I showed you some of the advanced water systems that of course cost billions and disrupt the infrastructure as well. but also some of the smaller scale, more implementable solutions, the green infrastructure, as the bioswales and the rain gardens, as you also already have in Java. I think there's no one solution that we can implement in the world. Semarang is really different than Amsterdam, for example. But I think that showing and sharing knowledge at platforms like ClimateScan or Brandasai could really help for us to understand the situation and also seek for maybe solutions that we can share as universities and try out, monitor, learn from, do more publications and spread the word. So I'm really happy for the future to work together and seeing if we can make a resilient place here. So I will stop with that and thank you for your attention. Thank you.
Okay, thank you very much, Prof. Floris, to the interesting presentation. The Prof. Floris is the delivery with how the Netherlands that adaptation for the climate change with the any of the strategy. Some of the strategy is that the water system management and then the flood control and suppose the green infrastructure and then from the about in the climate scan is the can to try if we can just okay. Now, ladies and gentlemen, we come to the second speaker today, who is Prof. Theis Andersen from Via University College. And Prof. Theis will bring the topic of insight into Denmark approach to climate resilience through renewable energy integration, sustainable infrastructure, and community-based solution. Let's give him a warm welcome, Prof. Floris, Prof. Theis. I'm sorry, the time is yours.
Thank you so much. Assalamu alaikum. And as you can see on my shirt, this is my first time in Indonesia. So I have to buy one like Floris. First of all, on behalf of Rege and myself, I'm very glad to be able to be here, and I'm so glad for the very warm welcome that you have given us. It's really a privilege and an honor to be here. Can I have my presentation? Yes. Okay, yes, so today I will tell you a little bit about how Denmark is preparing for the future climate. First, I will give a brief overview of the challenges that we are facing in Denmark, and then I have 3 examples that will show you how we deal with climate changes in Denmark. And the three case studies are very different in size. Okay, so just to illustrate, when I'm talking about Denmark and big projects and so on, I just added Indonesia on top of Denmark. So as you can see, Denmark is located in the center, and as you can see, Indonesia is so much bigger than Denmark. Actually, it's even bigger than in the entire Europe. So when we are talking about large scale climate adaptation projects in Denmark, I guess that in your case that they can be even bigger. So it's just to have a perspective of the scales here. Yes. So this is Denmark, Sweden to the right, and then Germany to the south. And just a little bit info of Denmark. We are the southernmost of the Scandinavian countries. We have 6 million in population, and we have this peninsula called Jutland on the left, and then we have a lot of islands. We don't have as many islands as you have in Indonesia, but we actually have fairly many in Denmark. We are not a high country or high elevation country. The highest point in Denmark is 180 meters above sea level, So we are very flat land with a lot of sandy coast along. We are not very big, but even though we are not very big, we have extremely long shoreline. So we have around 9,000 kilometers of shoreline, actually making Denmark the seventh biggest country in respect to the shoreline length. So that's why, so when we have a flooding or we have sea level rise, we really need to look into how to deal with that in the country. Oh, yes. So of course, how are we preparing for the future? Like anywhere else, we're doing climate mitigation and climate adaptation, and these two things, of course, should go hand in hand. On the left, you will see climate adaptation, and this picture is actually from what we call the Copenhagen rain event, and it was in 2011, where we have a huge cloudburst rain event in Copenhagen that flooded the entire capital, and we had more than 90,000 insurance cases. So it was a huge deal in Denmark. And after that rain event, then the government in Denmark decided that all municipalities in Denmark should make a climate adaptation plan. So within the next 2 years, in 2013, we actually managed to have a climate adaptation plan for each municipality in Denmark, simply due to this rain event. And then, of course, we have the climate mitigation, and in Denmark, we are really betting on windmills. So when we have a good windy day, then all Danish power is coming from green, sustainable energy sources. Oh. So, yes. So just a little brief information about where Denmark stands in relation to climate mitigation. Of course, we applied that we will honor the Paris Agreement, saying that we will keep the temperatures below between 1.5 and 2 degrees. I'm not sure that we will succeed in that one, but we will try. And then we have actually made a law in Denmark saying that that we in 2030 should have our CO2 level decreased by 70% compared to the 1990 level. So this is very, very ambitious, and it's really putting a big stress hold on the entire society. But I'm thinking that we are getting there. Yeah, and then we should have a fossil-free energy sector in 2050. And of course, all this is about to reduce the CO2 emissions. And then the Danish water utilities that plays a very important role in Danish climate adaptation and Danish climate mitigation. They have committed themselves to be climate neutral within 6 years from now. So very ambitious plans, but I think we will manage. So we used to say in Denmark that we are challenged from 3 sides in relation to climate adaptation. So we are challenged from above with more and more rain. We challenge from below because all the rain we have, it makes the groundwater level rise. And we also are challenged from the sides simply due to flooding from the oceans. And as you can see here in the blue boxes, let's say around 500,000 of the Danish houses are in threat of being flooded from below due to groundwater. And as you can see here, a huge amount of houses are in danger of being flooded due to sea level rises. So we have a big problems ahead of us. Yeah, just some info. Well, we expect all the models in Denmark indicates that we will have more and more rain in Denmark, especially our winters. They will be more and more wet. The summers will be drier, and then we will have heavy cloudbursts during the summer. The winters will be warmer than now, and we will also have warmer summers. And then, of course, we will have a higher sea level. The newest models in Denmark indicate that the sea level rise around Denmark will be around 0.5 meter in 2100. And of course, as the atmosphere has more temperature in it, then the energy level also rises, of course, so we will have larger storms and so on. Yes, so that was just a brief introduction to the challenges Denmark is facing, and now I'll try to illustrate some of the solutions that we're working with in three different case studies. And the first one is it's a governmental large-scale case studies, and it's about narrowing the Tyberon Canal. And if we look over here, you can see on the left map, you can see the little red circle indicates where we are looking at. And if you zoom into this area here, you can actually see. Can I point with this one? Yeah, here we have the entrance to this entire fjord system that we call the Limfjord. So when we have wind coming in from the west, then all the water here will be pressed into this fjord system, and that will cause flooding in this entire system. So what we're looking into is actually, oh yeah, and when we have flooding, we'll go back here. So the next picture is from this city down here called Lemvig. So if we look here, when they have water that has been pressed into the Limfjord, then what they have done here in the city has actually, they built a wall through the city in order to keep the water out. So it's very impressive. So this is just one way to do it. But of course, what they want to do is to keep the water out of the Limfjord. So what they're looking into here, the governmental state here, is that they will actually narrow this way where the water can be forced or pushed into the Limfjord. Now it's around, I don't know, 1.5 kilometers wide, and they want to narrow it down to around 250 meters. The price of this project will be around 100 million euros. And if it's done, then we will be able to protect more than 10,000 houses, and we will be able to save 2 million euros in flood protection every year. And if we have one in a 100-year event, then we will be available to save 120 million euros. So I think in this case, the take-home message here is that, and in many cases, climate adaptation solutions is almost always cheaper than doing nothing. So I think that's a very important topic here. Yes, let's jump to another one. This is what let's call a medium-scale climate adaptation solution. So this is from Horsens City, where VIA University College is located. And this is a typical Danish city where you have the city at the end of the fjord. And then you have all the creeks and streams are going out into the fjord. So again, here you have the situation where you can have water coming in, giving sea level rise. You can have water from behind that can get flooding into the system, and then of course you can have rain that comes down. And so what they did here in Horsens was that in order to keep this entire river system, it caused a lot of flooding in Horsens. So what they did. Yes. So what they did, they constructed a dam here. So they used this entire lake as a buffer system for the watershed behind, and then they put it out when they have room for it out in the ocean. But actually 3 years ago there was so much rain in the city that this dam was almost collapsing. So during the last 3 years they have elevated the dam with 1 meter and reinforced it simply in order to keep the city protected. So now the entire Horsens city are able to store a huge amount of water in this system up here. What they also did in Horsens city was that they opened up all the creek that was going through Horsens city was located behind the roads, as many Danish cities has, and now they are starting to open up, so give room for the water in Horsens. So again, here Boogaard is coming down here, and then it's going out here into the ocean. So now they're opening the entire city up. like this. So this is actually how it looks now today. So in Danish, this is called Creek Street, and it's because the creek is located underneath the road. And what they want to do in the future is to open the creek up again, and then make it much more livable. So the entire city. So this is the same building as you see here. So you can actually see this is a very old building. So you can see here that in the old days they were able to take the groceries in here and then to elevate them up in the houses. So we're actually restoring the city as it looks in the old days. So this is just some examples how it's supposed to look when it's finished here in Horsens. So of course it's going to make our cities much more green, as Floris also mentioned, and much more livable. So, and I think that is the second take-home message I will present for you here, is that actually these climate adaptation solutions, this is a unique opportunity for us to actually radically change our cities into something that is much, much better than we have now. Because at least in Denmark, we are going to change our cities. So when we're doing that, we are making them more livable, we are making them more green, we are making them more blue-green, as Floris also mentioned. And by introducing green and blue systems into the city, we will have cleaner air, noise reduction, biodiversity. We can also actually see that crime is falling when you have green areas in the cities. And we can actually also see that house pricing is rising. So there's only positive things by adding nature into the cities again. So in Denmark, we are actually using this opportunity when we are reshaping our cities, because we have to, in order to make them climate ready. Then we will think about this so we can make them livable. Yes, the last case study I have here is from New Rosborg or Vejle, just located south of Via. And in this case here, they are going to build a new residential area very close to Vejle Creek that is also flooded, are being flooded a lot. And we in Via, we have worked intensively very much with this area. Yes. So the project aim was to use high-density geophysics in conjunction with the geological description from boreholes, skis data, geotechnical data, and flooding maps to create a series of detailed planning maps so the municipality could use when they construct this new city area. So I will not go too much into details with these things because we are talking about climate adaptation today. But what we did here, this is the area. And it's around 1.5 times 1 kilometers in size, and it's actually an old landfill and recycle station. So it's there's a lot of contaminations out there. But what we did was that we mapped the entire area with high density geophysics. All the yellow dots here are sampling points measured from this system here, and we also did what we call the ERT sampling. So we are actually able to get a very, very precise picture of the geology and the hydrology and the geotechnical parameters in this area. So based on this, then this is an example where we have a borehole here, and here you can see the resistivity of the soil. You can see the geotechnical parameters in this case the shear stress. And when we go into the sand, you can see how many blows we have in order to have a good stability of the sediments. So what we can do here with all the drillings, where we were able to find the shear stress of the individual sediments down there, as well as the resistivity. And what we could see very easily was that in the upper 5-6 meters, we had very organic rich material that were unsuitable to build houses or buildings on. So we needed to have the pile foundation into the sand here. And so that was the main task. It was to figure out where was it actually the most suitable to build houses in this area. So just an example here, this is our ERT profile. So here we can start to interpret the geophysics into different types of materials. So in the top here we have fillings, then we have some peat, then we have organic clay coming in here, and then we have sand here. So we can start to build a very detailed picture of the geology and hydrogeology out there. We use that to build a 3D geological model that reveals how the geology and so on looks in the area. Yes, and all this 3D data, we have used that to construct a series of planning maps that we can use in order to go in collaboration with the municipality on how to best plan the city. So this is just some of the maps. Over here you can actually see the thickness of the low-bearing soil in the area. So we go from, in this area here, we have around 6 or 7 meters of unconsolidated material up to 20 meters here. Furthermore, if we do look at the flooding areas here, you can see that many of the areas here are extremely flooded. And you can also see this is actually, this entire house building area here is already flooded. So every time you have a big storm surge or big heavy rainfall, all this will be flooded in already now. So this is how it looks. So all the areas here with we combine the two maps we saw before, and all the areas here with the gray areas here, they are suitable for building construction. The green areas you have to either elevate them or do something else, and the blue areas you should avoid. So this was the map we provided for the municipality, and this over here you can see how it ended up when they constructed the city. And as you can see, they're actually building in places where we recommend they didn't do it. But what they have done here is that they have elevated this entire area with 5 meters, where they added a lot of soil. So it's very nice to see that a lot of the results that we have provided here actually had a big impact in how the city would look like. Yes, some conclusion and perspective. Denmark has established itself alongside also with the Netherlands as a global leader in the climate adaptation, simply because we have to. As Floris also mentioned, we are in so many problems that we need to adapt, or else we are in very, very big problems. Yeah, so we are looking very much into coastal protection, as you are here in Semarang. We have more than these 9,000 kilometers of coastline, so we need to invest in coastal defenses. We also look, of course, into flood management, especially from heavy rains. That is a big issue. And again, also, of course, for this rising groundwater, that is actually a huge problem in Denmark. And as Floris mentioned, within the flood management, it's often blue-green systems that we are looking into, such etc., green roof, permeable surfaces, and so on. And again, as mentioned before, every time we do a climate adaptation solution in a Danish city, we try to integrate it into blue-green infrastructure, so we make our cities more livable. So that's the main task here. Yeah. So as mentioned, lastly, we are trying all the time to transfer our city from going from these gray cities to blue-green cities that are more livable and nicer to live in. So I think that's it for me. So thank you for the attention.
Okay, thank you so much, Prof. Theis Andersen, for your enlightening presentation. I believe we all have gained some valuable insight there. Now, ladies and gentlemen, we move on to the third speaker. There's a speaker that's from the Professor Dr. Insinyur Slamet Imam Wahyudi from Universitas Islam Sultan Agung. And the Prof. Imam, there's remember, yes, the participation, and please welcome Prof. Imam. The time is yours.
Yes, oke. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, semangat ya. And guten Morgen, Floris and Eric. And Denmark, good morning. Good morning ya. Little bit different ya. Guten Morgen and good morning from Denmark. Thank you for all participants in this room, and also especially from online, yeah, because we surprised that online participant now is full, yeah, and I asked to committee that the capacity online participant is 300. So I think there's more than 300 online participants in this. Applause to all participants. Yeah, I happy from our colleague from Netherlands, Floris and Eric, and then from Denmark, Theis and Rico. Yeah, I know Denmark first from badminton player. Yeah, the legendaries. I remind Morten Frost Hansen. Yeah, and no, the badminton player I know. Victor Axelsen, yes, winner the Olympic, yeah, and yeah, and the Denmark people call Danish, yeah, Denmark people, Danish, Dutch people, Netherlands, Dutch, and Denmark people, Danish, the side, okay. And Dennis is the popular name in Indonesia. Yeah? My nephew also named Dennis. And I know another thing in Denmark is a palm brand, yeah, Grundfos. Do you know Grundfos? Grundfos is one of popular palm in Indonesia also, and made in Denmark. Yeah. And in Indonesia, in general, Grundfos 3 times more expensive, but stronger. and we know that's because Floris and Eric have already come here, and now the Timnas Denmark, Netherlands confused and headed because some good player moved to Indonesia. And be stronger national team football in Indonesia right now. Okay, I like present our paper, how to mitigate flooding and to adapt climate change. Yeah, I like present first introduction. Many disaster flooding in Indonesia, especially in north of Java. I will present, and then why and what climate change phenomena. We know sea level rise, one of climate change phenomena. And then heavier rainfall, because rainfall the time to time heavier, more. And then one specific climate change, maybe in Indonesia, in north of Java, is land subsidence. And the third, I like present about how to adapt climate change. We make in 3 strategies categories. First, nature-based solution, and the second, infrastructure protection, and third, early warning system and mitigation management. Yeah, this point we have discussed with Theis. Yeah, Theis also make the three categories: nature-based solution, infrastructure protection, and early warning system. Yeah, we will discuss about how we implement the three strategy categories and with our plan of the three categories. And I will finish with the conclusion. Yeah, last years we have a big flooding, including in our campus. Yeah, our campus is also a climate change example in Java. Yeah? So last year's the rainfall 10 to 228 millimeter a day. Yeah, we know that in Europe rainfall intensity is only about 50 millimeters. Yeah, 50 millimeters. But we unfortunately have big rainfall. Yeah, already every years. Yeah, the last years to more than 200 millimeters. So 4 times bigger, heavier than in Europe in general. So it's our challenge. Yeah, our challenge. Yeah. In that sea level higher than in Indonesia. Maybe that's in 7 or 8 meter. Yeah, lower than sea level. But in Indonesia, like UNISSULA, maybe about 50 centimeter lower than sea level. Yeah, sea level can be 1.5 meters, and UNISSULA have 1 meters elevation. So we have about 50 centimeters lower than sea level. So we have the strategy not only protected but also adapted. Yeah, protected by seawall and adapted. Now we make our land higher. Yeah, and unfortunately make your inconvenience because many construction right now. Yeah, maybe next your visit on June better. So and not only in Semarang but also in some area north of Java, Brebes, Tegal, Pekalongan, Semarang, Demak, and Jepara, and some of the regency and city we will visit. Yeah, next Wednesday. Yeah, Pekalongan, Semarang, and Demak. Wednesday and Thursday we will visit this location. And the three possibility action to handle the tidal flood. Yeah, first migration. Yeah, we move to another area higher. Yeah, we move to the hill. Yeah, to the hill, but our campus UNISSULA not have this policy. We still stay in our campus in Kaligawi. Yeah, we still. So we need another action. Yeah, first protection and then adaptation. And now what action and innovation are needed to adapt climate change? Yeah, we will discuss today. Yeah. Yeah, this map consists some regency and municipality who have cooperation with our campus. First in Brebes and then Tegal, Pekalongan. Pekalongan there are two. First city of Pekalongan and regency of Pekalongan, and then Semarang city and Demak. Yeah, we have a cooperation with this government in north of Central Java. Yeah, some example from Brebes Regency. We have a concept policy system, and in Brebes also we have started to implement floating market, and in Brebes also have mangrove area protection. Yeah, Brebes have one of the biggest mangrove plantation. Yeah. Yeah, maybe on Saturday we can Floris we bring to Brebes right Saturday, but Theis and Rico have already depart to to Denmark, and then Tegal is also have some border protection, and we have already ride together with Floris and Eric, for the border system protection in Tegal. Yeah, and then Pekalongan we will visit on Wednesday. Yeah. Yes, because there are column, yeah, so we cannot see the direction. We will visit Pekalongan, and some area have protected by border system, seawall, and have some long storage in Pekalongan and pump station in Pekalongan Regency and Pekalongan City as well. And in this area, even though no rain, but this area flooded. Yeah, not one years, but almost every month. Yeah, and also in Semarang, have flooded in the central city of Semarang, Simpang 5. We can visit this location, and old city in Semarang, or we call little Amsterdam, old city in Semarang. And we have already protected by border system. Yeah, but when have extreme rainfall, more than 150 millimeter a day, almost all lower area in Semarang flooded, yeah, included our campus. And this one was situation as our campus during flooded. Okay, and Demak Regency and Timbul Seloko we will visit on Tuesday. Ini pas the flooded area. Yeah. This area not only tidal flood, but every time flooded. So the area become the sea. Yeah. Miss Mila, she worked many in this area, and she will bring us to this area next Thursday after inauguration of Professor Heni in the morning, and then in the afternoon we visit this area. Batunya habis ya. Give a moment. better. So now we attend to climate change phenomena. Principal climate change phenomena in north of Java in our country. First, rising sea level. We have rising sea level not so high. According to national plan, we have about 8 millimeter a year. But we have the biggest phenomena in Indonesia is land subsidence. Yeah. In our campus, according to the data, we have land subsidence about 5 centimeter a year. Yeah. And we have also measurement. And then the climate change phenomena in Indonesia is heavier rainfall. Yeah. Last time extreme rainfall more than 150 millimeter a day. Yeah. But last years in Semarang have more than 200 millimeter a year. And another area have more than 200, almost 300 millimeter a day. Yeah. So it's a very hard, heavy rainfall. Yeah. Now the climate change phenomena is change in weather pattern. So for agriculture, we also change the time of plantation. Yeah. Because change in a weather pattern, and then we have urbanization and land use. Okay, this is a high water level that I follow. Normally, the maximum high water level, as I know, is about 160 centimeter, 60 or 65. But last year's high sea level attend to 210 centimeters. So all area in harbor, central harbor in Semarang, flooded. Fortunately, our seawall is 325 meters. So we save this area safe during highest sea level. Yeah, and so we have an alternative. We move, migration, protection, or adapted. Yeah, some area have already moved. Yeah, some area in Sayong. Yeah, some area move. Yeah, some people move, but maybe the majority still stay in this area because their work. If they move, they cannot work. So still live, even though every day flooded. Yeah. Okay, and adaptive. Yeah. That's data from our colleague. The area land subsidence in our city, yeah, in Semarang. Yeah, the zero less land subsidence, 0 to 3 centimeters years, and then green, light green is about 6 centimeters a years, including our campus. Our campus is over there. Yeah? So it's about maybe 5 centimeters a years, and then there are some area more than 10 centimeter a years with a dark green. and then heavier rainfall. Yeah, we have data rainfall in Central Java, and the what's the color? Red or violet or purple? Yeah, purple extreme. Yeah, extreme rainfall more than 150 in some area, and last years, even though the biggest rainfall is in this area, but flooded in this area, because a river flow from this area to this area, along of this area. So last years we cannot pass this city, almost 2 weeks and 2 times 2 weeks and 2 times this area because flooded. And I also visit this disaster, because some river dike collapsed, and then area flooded during more than 1 week, and traffic stopped for this disaster. Okay. According to this, also the reference, the climate change as precipitation increase or heavier rainfall and sea level rise, and also there are non-technical population growth and economy growth can also give impact of climate change. And this one is the prediction of high sea level. Yeah. Okay. And then how to adapt climate change? We can make in 3 categories strategies. First is we call NBS, NBS, nature based solution, like mangrove, restore wetland, spongy area, and then protected by infrastructure, the second, and the third, early warning system and mitigation management. And I take some reference, almost same categories. So I like to keep these categories to work how to adapt climate change in Indonesia. And we have some experience research cooperation for the 3 categories. First, a nature-based solution, infrastructure to protect climate change, and early warning system and mitigation management. Research for nature-based solution, mangrove rehabilitation. Dr. Hermin have already many work about mangrove, who is moderator today. And then spongy area, spongy area, also from Department of Planology, how to make area spongy, easier infiltration. And then we have also program rechanneling for flooding. Some river lower flow rate, we can divide to the river has more flow rate. And then infrastructure to protect climate change. We have Semarang policy system. Semarang almost all protected by policy system. Maybe 80% area in Semarang protected by policy system. But remind that we can support only less than heavy rain. Extreme rain or heavy rains, some area heavy rain is already flooded, like in our campus. Some area extreme, they have flooded. Also Pekalongan, Tegal, and Brebes. And we also we have another program ongoing, coastal reservoir. Coastal reservoir behind of our campus. Yeah, we will have 200 hectare coastal reservoir. We hope this with the big coastal reservoir, our campus more safe of the flooding. And one of our students will defend tomorrow about coastal reservoir, but how to prevent sedimentation to coastal reservoir. Because if a coastal reservoir fill always sediment, we cannot use this storage. Okay. So the third is early warning system and mitigation management. So we have also student work for flood early warning system in Ciliwung, Jakarta, Pak Agung, and then floating building. Ravini have work more about the floating building, and also I have a student who work piling foundation for building and how to move a piling foundation when have a phenomena reaching sea level. Okay. Some example of mangrove in north of Java, Dema. I think we have visit to this area, Bumila. Mangrove, yeah. Close of Timbus Loko, the campaigns, the area become the sea. Yeah. A long time ago, this area is agriculture area, but now agriculture and aquaculture, and now it's the sea. We have also mangrove, and the biggest mangrove area is in Brebes. This case of nature-based solution, yeah, nature-based solution. Another nature-based solution action is regenerating to minimize flooding in Semarang. I involve also this program, regenerating, and we have also another regenerating in Rembang, but not for flooding, for drought. Some area drought, and for example, this river more water, and this area less water, and we send the river more water to the area drought. And also we have a student who work in Lombok, West Lombok, more water, but middle and East Lombok drought. So we send the river from West Lombok to the middle and the east of Lombok. And we have also another nature-based solution, spongy area. Yeah, in Semarang we have cross channel. Yeah, cross channel. I think it's the excellent idea from that engineer 100 years ago. They make a cross channel in Semarang. So Semarang divided in low area and high area, and in between that's engineer make a cross channel to stop water from area to low area. Yeah, it's and still function this channel, and this channel connect the two big river, East River in Semarang, East River and West River. So if there are no cross channel, maybe Semarang always big flooding. Yeah, because stop it by this cross channel. And the hill we have a program for sponging, make more infiltration, yeah, to minimize flood. Yeah. Okay. And then yeah, we have another research student, Aulia, study about median, root median, and they put storage and infiltration, and when water in the median area high, we flow the water flow to the normal drain. Yeah. And also student from Banjarmasin, Gunawan, Prof. Ratekso, who is the promoter, have a study about porous pavement. Maybe similar that Theis research. Yeah, we call porous pavement. Yeah. Water can flow, infiltrate in the pavement. Again, other nature-based green infrastructure, and one of problem green infrastructure in Semarang is Nusrep. Yeah, I think will start in this years. Yeah, in this years. Okay, and then infrastructure protection. We have some or many police system, and in Semarang, and then in Pekalongan, in Merican area, and this pump station use green force. Yeah, use green force this area. We will visit this area, and because I follow this project since feasibility study. Yeah, so I on this project, and they use green force pump station. Yeah, and they have a long storage. Yeah, 5.2 meters, 0.2 kilometers long storage to protect this area, and with the storage, long storage, and then pump station, 2 pump green force and 1 pump KSP. KSP brand. This location we will visit Wednesday, and then we make more water storage, including reservoir, coastal reservoir behind of our campus. Yeah, this coastal reservoir behind our campus is here, and then we will have the biggest coastal reservoir, 200 hectare area. Yeah, then integrated with toll road project. Toll road as function as dike, as dike, and then area will be storage and pump. Yeah, we hope pump will operate by green force, hopefully. Yeah. Okay, and then we have another strategy as early warning system. We have PhD Dr. Agung have finished 2023. They make a flood early detection system in Jakarta, Ciliwung River. And then we have another emergency protection part of early warning system. We have a flooding building, and in this evening we visit this area, yeah, because only of the building, yeah. And Prof. Pratikso and Prof. Beni as promoter and co-promoter this PhD student make this floating building. Yeah. And we have also the type this protection Bu Asnun, yeah, it was finished also 2022, and now ongoing Bu Repi for the elevated house or piling house in Sumatra. Okay, our conclusion to adapt climate change, we have three strategies, categories. First, nature-based solution. Some activities have already done, and we need more plan to implement nature-based solution. And then the second, we continue infrastructure protection using policy system, not only build the system, but also how to better operate and maintenance the system. And then the third, we continue to how make early warning system better and mitigation management. Yeah, and not point to point work alone, but we have combination. Yeah, combination like in UNISSULA, combination protecting and adaptation. Yeah, because only protecting not so we UNISSULA have policy also adaptation make more high this area. Okay, I think it's all. Thank you. And tak ya, tak, tak terima kasih. Tak is terima kasih in Dutch, in Denmark ya. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Prof. Imam, for your exciting presentation. Please give applause for all speaker in here. Okay. Now that we have heard from all our speakers, we hope you find the insighted information. And in session, there's 5 speakers, Prof. Floris, Prof. Theis, and Prof. Imam that put the presentation, and maybe Prof. Eric and Prof. Rike, and that can be additional comment regarding this presentation. Now we will open the floor for question. If you are in the audience, please raise your hand, and I will bring the microphone to you. And for those participation online in Zoom meeting or in YouTube live streaming, maybe you can submit your question from the chat room, or in Zoom meeting you can click the raise hand button. So for the participation now, with the first floor to discussion, maybe in the audience and the room of seminar, please ask for our speaker here. Maybe for our audience, that's kind of the question from all of the speaker here.
Please, students, do you have any question to the speakers?
Yes.
or maybe from our guest from Novi, Pak Agus, Bu Heni, or Pak Rusli. Question to the speaker.
Okay.
Yes. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
I'm Rusli. Siswa gantian tanya ya. My narasumber. Prof. Imam said,
Sorry, Pak
Okay,
Pak
yeah.
Rusli. This question is delivered to. This question is direct to.
maybe from or Miss Prof. Yeah, from for Prof. Floris. In of solution of flood mitigation is in Semarang, actually in UNISSULA, Universitas Islam Tulungagung, that we hire the road elevation. How effective this solution compared to the other solution? Because I think it is some short-term solution, not on my some is a panic solution, because everyone said when flood is coming they are all flood. So I want to know from maybe Prof. Floris, Andersen, that higher the elevation of road, is it a good solution or be bad or panic solution? That's what my question. Lanjutnya nanti mahasiswa ya, nanti yang tanya poinnya dapat skor A ya dari Pak Eko. Terima kasih. Thank you.
Thank you. Please, Floris, to make the addition.
Yeah. Okay. Thank you for that question. Yeah. Indeed, it is one of the solutions. Higher the roads. If it's a good solution, really depends on what we are focusing on. It's not a long-term solution because it will be higher in 100 years, or so that's the long term. Of course, there's cost involved as well. So it's a bit hard to say, is it a good solution? It's a good short-term solution. It will the problem of at the campus for now. The only thing is maybe to think about, if we are changing the infrastructure, is it a long-term solution? So what would be the alternatives? One thing which is mentioned, of course, is the bigger picture. So we have a pop system, and just then you don't need to elevate the roads. But of course, that's quite expensive. That's the bigger picture. A temporary solution, not long term, and other be more out of the box. So another solution could be flooding is only 1 or 2 weeks a year. So it could also be that you say, what we do in other countries as well is to accept it, that there's flooding, that you actually do things online instead of going to the campus. That could be one of the things that we can think about. That's very low cost, but of course very disruptive. Or maybe think about a long-term solution that might be, why wouldn't we implement a floating road? That could be quite nice at the campus as well. Doing research, it relates to a lot of professors here as well, students doing that part. So that's one way I'm thinking. I'm not saying it's a good solution or not, but there's a lot of think about to having a long-term solution which is cost-effective, and maybe also if we implement a higher road, maybe there are more functions that we can make, because now it's being hired with grounds. But maybe we could make it a hollow road, or that it actually also stores water, maybe for drought times, and reuse the water, flushing toilets, or so that makes it more expensive, but more benefits as well. So That's a very long answer, but I think it's a good short-term solution. But maybe we should more think about long-term solutions that might be more innovating and interesting for a university to do more research and have a best management practices maybe for Java or even the whole world. Yeah. I hope that answers your question.
Okay, thank you.
Okay, thank you. Maybe Prof. Eric, they can comment.
Yes.
Please.
I like the threefold solution you mentioned. It, of course, is not you just move an entire university to another location, but it would be worthwhile to think about future developments if where you want to develop in. What you mentioned, the long decisions, and because migration at this very moment is not an option, then you have to protect your premises, and if you do this with hard solutions, hard civil engineering solutions, and that's what it is, raising the roads, etc. I think it's important to keep in mind what was the natural situation. We block something. We block something, and I liked in experience a problem, and actually you should causes this problem, and that's why I like this. You have to think about, can we bring back the natural solution? Do we block the This is the best. Adaptation doesn't ask something from climate. No, it asks something from us. We can adapt rainfall. We don't can adapt storm and etc. So we have to adapt. We have to do something, and we have to change something in our natural behavior. And I think that's important to realize that it's not just a technical solution. It also asks something from us.
Okay, thank you, Prof. Eric. Maybe we would like to comment from the case of the Denmark. Maybe is there also the choose of the pricing of the road, maybe is applied in Denmark? Maybe you can explain for me to insight this.
Yeah, thank you for the question. It's very just to support what has already been said, that it's also a solution we use in Denmark. Is it a long-term solution? Most likely not, as Floris mentioned as well. But I guess it's a good short-term solution, say, and again, you always have to look into what do you need in the long to medium term, and in this case, elevating the road is most likely a good feasible solution in this case. Could we do something more? Could we do it better? Yes, of course, but sometimes it's doable, and I think it's like this is a very doable, good solution in the short term. Just to follow up on what I already said, there's one solution here in the long run, and that is climate mitigation. So it is to lower our CO2. The only solution. Adaptation is only adapting us for the changing climate. We want the changing climate to as fast as it is doing now, we have to change the CO2 level. So climate adaptation, climate mitigation goes hand in hand. You cannot take one out from the other. So I think that's an important aspect to have. We also, like illustrated here, we also in Denmark uses roads as dams, dikes, and so on. So we also use infrastructure as climate adaptation solutions. Yeah, and as Floris mentioned, there's many possibilities. Tomorrow I will have a presentation about a permeable pavement, a climate road, where we have integrated a geothermal system into the roadbed. So there's plenty of opportunities to do innovative things around the around the road. So as Floris mentioned, I think out of the box and to have some of the bright students here to innovate on the system, to see if they can find some new funny good crazy solutions that could be the future.
Maybe I can just very agree with all the things that already been said, and then last comment could be that I really acknowledge that that this university is located in a very difficult place. But on the other hand, this could also be an opportunity for you and doing applied research on your own spot. And as Eric mentioned, you could think out of the box and do climate adaptation, where you can do continuously measurement on how your new ideas work just outside of the door.
And I think also you can say that climate adaptation is like an insurance. The better policy you have, the more expensive it is. So it's exactly the same here. The more protection you want, the more expensive it is. So it will always be a cost-benefit analysis, saying how good a protection are you willing to pay for. And so that's the in Denmark we just made some investigations showing that in relation to urban water, like rain, it can only cost beneficially make sense to secure it for 50 years ahead. Whereas if you're looking into storm surge or floodings, then you're within 150 ahead. So you need to also have that into mind. So I guess in this case it's probably the cheapest, the best solution at this moment for you.
Okay, thank you. Rosli, this is clear for you? Okay, thank you. Maybe another question from the audience, from the student, please. Oh, okay. Bu Mila, maybe you can speak over your question and direct to whom? Please, Bu Mila.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for the presentation. I have one question maybe for all of speaker about our program new president. They want to build about giant seawall. Giant seawall because our new president have a benchmark from Netherlands about how they overcome the flood with the giant seawall. As I know, or my friend know, that giant seawall is not good solution, because they will block the sea or the coastal, and the impact is from to the fishermen, because they block the coastal. Many fishermen cannot have work in the coastal area again. So maybe from your side, from Denmark or from Netherlands, the giant seawall is the good solution for Semarang, not only Semarang, for Central Java, because our new governor too have a program to giant seawall to build to stop the overcome the flood or tidal flood. And the second is about from your research, is any local knowledge that you can give from your research, like maybe you will see when you go to Timbul's Loco with me, that local knowledge is very important to adapt the situation to overcome the flood or tidal flood. Like in Timbul's Loco, Pak Imam pictures, they have built the, what is it, path with the bamboo or with the with bamboo and wood, so they can cross to the other area with without no flood anymore. So I think not only the hard infrastructure, but the soft infrastructure is very important to adapt the situation in like flood. And second, I think in there is a good a good insight from Timbul's Loco. As Pak Imam said, they have three strategy: migration, protection, and adaptation. In Timbul's Loco, they don't go. They still live in the Timbul's Loco because they attach with the place. And we said the place attachment, place identity, because they live with the location, they have work here, work there, and they have inheritance there, they have religious there. So even the situation is very suffer for the people, they still live there. So from the situation we have framework about how they live with the with the disaster. How they live harmony with the disaster without the know how to adapt the situation in this. Thank you.
Well, thank you, Ms. Mila. Please welcome to Ms. Prof. Floris and Prof. Eric, and then the Prof. Eric can to.
Thank you, Mila, for a great question, and good to see you again. Yeah, so maybe just repeat the question as well. The first one was about the flood wall, and of course the effects it has. Is it a good solution? It always depends on who you ask. You're more a social scientist, I'm a civil engineer, we might have a different opinion about it. But I think, as research indicates, even in the Netherlands, we have flood walls, dikes, very civil engineering, large-scale solutions. Because safety first, of course. Flooding is not something which is fun and disruptive and kills lives, of course. But what we learned in the past is that all the great infrastructure, which is very costly and very effective, of course, keeping the sea out, has a lot of side effects. As for the fishermen, as you say, or the biodiversity, because fish cannot migrate anymore. And actually fish is our life, because it's food, and it's also very important. And we have to ask ourselves, it is a problem, but how long is it a problem? Like elevation of the road, maybe it's only 1 week or 2 weeks, or maybe we just have to close it from the sea, only maybe 1 or 2 days. So that depends, do we need a flood wall the whole year? And what kind of flood wall is it? So I think flood walls are necessary, especially if a lot of lives are in stake, and there's no debate about it, safety first. But even in the Netherlands, the flood walls are being opened now. So most of the year they're open, so you can migrate, the fishermen as well. And so maybe it should be a semi-flood wall, for example. Or we should more accept that we have sometimes controlled floodings. That's also a possibility, which is, of course, maybe a bit more disruptive than a large flood wall, but at least it doesn't cost that much money or is that disruptive. And maybe the second part of your question is very important. What I learned as a civil engineer from TU Delft, which is really about gray infrastructure, that the best solutions are not necessarily those great gray walls, but it really depends on the people that live there. Because indeed, it's disrupting their lives with their culture, their fishing habits and everything. And if we go for a solution, they should be consulted or actually be in charge of what it will be changing their lifestyle. So, and that also communicates with our two social science and maybe technical science that it's all needed to come up with a good solution. Yeah. And then I moved the microphone to Eric.
Okay, thank you. Well, let me say this. As you may know, in the Netherlands we build a lot of dikes and dams and exported the knowledge of it to other countries. But with the knowledge of we probably would have acted differently. Floris mentioned in his presentation that the barrier dam, which saved us from raising dikes for about 300 kilometers along the Lake IJssel in the middle of the Netherlands. But today, at this very moment, they are renewing the dike and not just having just a closed dam, but have it more open so that the water can flow in and out. So that's one thing for biodiversity. It's very important to leave it open somehow and just close it in extreme situations. And the second thing is that you mentioned the people that live alongside the dam or the wall. Of course, they have to continue doing their work and being able to travel alongside. Otherwise, you block their future, and then you have to ask the question, what's worse? When we built the barrier dam, a lot of fishermen lost their jobs just because the lake became fresh water and they couldn't go and fishing there. So to decide about this not just needs what you mentioned, civil engineers. No, it has to be a multidisciplinary team about people caring about the inhabitants living there, the economic situation, and of course the technical aspects.
Okay, thank you. Maybe Prof. Theis or Professor.
Well, thank you for that very great question. I came to think of an area in Denmark where we, long time ago, did a lot of pumping to increase the area for agriculture in the western part of Denmark, having straight canals to remove all the water very efficiently. And then we figured out later that that wasn't maybe that's a good idea. The soil wasn't that good for agriculture anyway, and it really destroyed the biodiversity of the area. So 20 years ago, we started moving it back, removing the pumping, making the river back to its natural floating again. That, of course, had a great impact on people. A negative impact for the people that had the agriculture there, because now it was a flooded area all year long. So they had to do agriculture somewhere else. They got, of course, help from the government to move, but a positive impact on other people. For instance, this is a very important tourist area in Denmark now, so we have tourism growing in that area of Denmark. So sometimes one impact could be negative on some people, but create a life for other people. So this also to keep in mind.
Yeah, I don't think I have anything else to add.
Okay, thank you for all our speaker, and maybe we can move the online participant, Zoom or YouTube channel. Maybe the online participant, you can submit your question through the chat function or click the raise hand button. Maybe from the committee, please present from the Zoom virtual in the virtual room. Okay, maybe from the participation in the online room, if there are any question to our speaker, you can click the raise hand button, or you can type your question in the chat room. The committee is any question from the chat room, or maybe the raise hand. Okay, because in the room or in the question for all of the speaker, maybe Prof. Imam, can you some of the comment if or the question? Yes, please.
Mbak Mimi, any question from the online participant?
From online, we haven't got any question, Prof.
Yeah, I like to continue the what's about giant seawall? Yeah, as Floris says that giant seawall it's not all beneath people, and I think also that can apply in partial area. In east of Semarang, included our campus, one of part of area is Semarang will be protected by toll road as function giant seawall, yeah. And the government prepare big storage, so partial application giant seawall from Kaligawe to Sayong. And I note also from Floris that giant seawall not close the estuary or river, but estuary and river have to still open to operate water boat water transportation, and also fishing activities, and I think the biota sustainability. And then second one is about the make road high in certain area. I said that this one of adaptation, yeah. But this solution is short-term solution. Short-term solution, because the time to time some water higher, and we need to make again road or area higher, and this is a very costly. Maybe for the area that have money can make a higher area higher, but the majority cannot pay this the method, yeah. And especially people who live there, I think it's very hard, yeah, to make their house higher. So I think it's a very short solution, and the sustainable solution that I think like in Netherlands they use policy system, but we have a different challenge in Netherlands, have different land and sea level high, but in Indonesia have heavier rainfall. Yeah, so our challenge difference. Yeah, we have a challenge how to manage heavier rainfall, and how to manage water elevation by storage and pump station. Yeah, so yeah, the long term solution is protected by policy system. This need storage and pump station, and also I think stakeholders participation. Yeah. People who live in this areas also have to support the system, yeah, for operate and maintain the system. Yeah. Last time when we done apply policy system, we throw the garbage on the river, and garbage will flow to the sea. But no, we cannot do that, because the garbage will attend to the pump station. So the culture also have to change how to manage garbage, and more clean the make more clean the area. Yeah, because policy system need water clean. Okay, that's all from my opinion.
Okay, thank you, Prof. Imam. I would like to from the audience here, because okay. Okay, I don't see this. Okay, there's the question from the chat room. Okay, this. Okay, this from Miftah from Baperinda Kota Pekalongan. This facing Pekalongan is okay. Thank you for chance to ask given the toughest challenges currently facing Pekalongan city in dealing with climate change is public awareness and behavior change. It is also faced in Denmark and the Netherlands. How does your country deal with this? Maybe from the Miftah from Kota Pekalongan, close to the from the Netherlands and the Denmark. How the past this the country deals with this? Maybe it's. Yeah.
Shall we maybe start with Ricky? Then you have it easier. And then we go to me. And then I say, I agree with all three. But maybe you're first.
Well, thank you, and thank you for that very important question. Yes, it's definitely something that we are dealing with in Denmark as well. People in Denmark really not prefer to live nearby the sea, preferably so that you can see the water from your house, and that definitely gives some issues. One of the things that is discussed in Denmark currently is that we have a great insurance in Denmark, and for now everybody pays the same amount for the insurance, but currently we are discussing whether the people living closest to the sea, where is a high risk of flooding, if they should pay a higher part of the insurance than the people that decided to live more safely.
People in the Netherlands feel safe behind the dikes, and they never worry about water safety and how the situation is. And now the Dutch government comes with remarks, please be aware that also in our country it is possible that we will have a flood, and are aware of that. And if there comes a flood, where do you go to and how do you act? And we don't know. We are not used to the idea, and that's what we are facing right now at this very moment, that we have to warn our own people in the Netherlands, please be aware there might be a flood also in your region. And they started some kind of website where you can check your village and your location, your house. If there is a flood, then in your situation the water level will come up this level. And then you have to ask yourself, what am I going to do?
And I agree.
Now, maybe the last thing to say, because it's addressed, of course, also in the question that behavior change and raising awareness are very important, and that's being done by different ways, as being addressed by Ricky and Eric. One of the things we do as well is a seminar. This is about raising awareness and also showing a lot of solutions. Of course, that doesn't have to lead to behavior change, which is totally different. Mostly behavior change happens after something bad happened, and we have to use those moments to show what the options are for people, and use those moments to raise the awareness that the climate is changing, because a lot of people still don't believe in a climate change, even if they don't really feel that changing. And I think because that was, I'm just raising or repeating what was in the question. I think all means to raise awareness or have behavior change are very important, and there are different ways to do that. Thank you.
Okay, thank you very much for all the speakers. I'm sorry because the time is running out. Maybe all of the participants, if you are any question to all of the speaker, you can write send to the committee, and then from the committee then forward to all of the speaker here. Okay, now that we have heard from all of the speaker, maybe from this. Let me summarize all the speaker. The coastal area, particularly vulnerability to climate change. There's adaptation for strategic in this region, and this is from the listener from the Netherlands, Denmark, and Indonesia. It can be any more focus to enhancing resilience through such as the water management system and sustainable land use planning, and adapted the green infrastructure in the Netherlands. And such of the Denmark, there's adapted to the coastal protection, and then flood management, and then the climate resiliency city. And in Indonesia, we know the adaptation for the enhance the climate change is according to the Prof. Imam, this can boost the natural based solution, and the second is infrastructure protection, and the last is early warning system mitigation. Ladies and gentlemen, remember the discussion don't have to stop here. Let's continue to connect and share knowledge beyond this seminar. And thank you for your thoughtful question and for engaging so passionately with our speaker. As we come to the end of the seminar, I would like to express my gratitude to our speakers, Prof. Rike, Boogaard, and Prof. Theis from via University College from Denmark. And thank you for Prof. Imam Wahyudi from UNISSULA. Our grateful to our speaker from Netherlands, Prof. Floris Boogaard and Prof. Erik de Boer, for their valuable contribution, and to all attendees to your participation. Have a wonderful day, and we hope to see you at our future event. Now I'll go back to the MC and thank you.
Yeah, so we give big applause for all speakers and moderators today. What an interesting and very interactive discussion. Well, ladies and gentlemen, before we close our agenda today, we please our Dean, Mr. Abdul, to give the certificate and also souvenir from UNISSULA to all speakers and our moderators today. On the stage, Prof. Please stay on the stage. The first certificate and souvenir will be given to the team from Hans University of Applied Sciences, Floris, and also Erik. Yeah, of course, take photo together. We please Bu Novi, Pak Rusli, and also Pak Agus, and other lecturers, and also Mas Rio, please come to the stage to have photo together with moderators, with our dean, and also with the speakers, please. Okay, thank you everyone. The audience, please, we give big applause once more to all speakers, all guests today. Oh, unggul, okay. Premier, unggul means premier, premier. Oh, unggul. Okay, thank you so much to everyone.
Okay, we meet all of session today. Thank you for your active participation, for your attention in this insightful session on hybrid international seminar on innovation in climate change adaptation for coastal and delta area. Today we have explored many ideas to conduct the next research in our university. Thank you once again for all the speaker and moderator. And I am as a master of ceremony. Let me close this session. Okay, once again, the student have to want to take a photo with all speakers in front of the stage.